One of the important properties or design principles that we can use when we're trying to build abstractions that help us improve the security of our applications and prevent us from making mistakes is to ensure that we don't tightly couple our data to our security state. Now, what do I mean by data? Well, I'm talking about the things that our application is doing as part of its normal function. That, let's say that we removed security for the moment and we just needed to make decisions about the data. The things like the values that the user is inputting into our user interface. I'm talking about the temporary variables that we're creating that are based on that data. The data that we use to do calculations and methods, or the key names that we decide to store data with. We want to separate those from the variables and the flags and the other things that we're using to indicate how to securely process that data. So if we take that principle and we look at this code base that we just looked at, what we see is there's a problem here where we're violating this principle. And that is, we're coupling the security state of the application to the data state of the application. And that is, this key that we're creating and passing into this store data method is serving two purposes simultaneously. It's serving the purpose of deciding how we associate and store that data on disk, and the security decisions that are made with respect to where that data gets saved and how it gets saved. So we're simultaneously coupling this key to both the security state of the application and the data state of the application. So we have a simultaneous meaning for our key that's causing problems. If we go and we change our key, as we just saw, it can unfortunately change our security settings. So if we make a mistake in the key, we will suddenly be making a mistake in our security settings. And what's also problematic is we've got a key and a set of code that's being used to decide security settings from the key's value that's very hard to test and prove from a security standpoint is correct. So if we look at this code, it's not immediately obvious if the code is always going to work. And if we hadn't happened to find the right test case to show that this code doesn't always work, we might assume that it was okay. So by coupling our security and our data state, we're not only having the ability that our data can change our security in a way that we don't want to happen, but we're also making this much harder to test and prove. The other problem with coupling the data and the security state is if the key was something, for example, that was provided or potentially interacted with data from the user interface or from an intent or some other application, then we could end up in the situation where an outside attacker can inject or easily manipulate the security state of our application. For example, by somehow manipulating the keys so that we save secure state in an insecure way. And these are the types of flaws that attackers discover every day. They discover things that the developer didn't think through that expose the application to attack. So how would we actually improve this specific code example? Well, the first thing we would want to do is separate this data state and the security state. And we could do that fairly easily by introducing a new method parameter that is secure. That is, we want to have the security state in a separate variable that is not tied to the data state, the key and the value that we're saving. So by separating these out, we're helping to prevent the ability for other people to attack and to have some of these issues we just looked at. And it's definitely an improvement. But if we look at this code, is this the best we can do? And I think the answer is no, this is not the best we can do. We can still do better than this. Yes, we can apply a decoupling to improve the application by separating the security and the data state, but this alone doesn't get us a more secure abstraction. It gets a possibly more secure abstraction, but we still have some other issues.